This is the last session of ITCS. Thanks for sticking around. So there are three talks. So the first one, fine-grained I/O complexity via reductions. So this paper is kind of a really nice new foray. So as most of you know, so the study of fine-grained complexity has kind of had many really nice recent successes. So this is sort of, in total, it's done a good job explaining connections between many classic problems in P. So all pairs shortest path, edit distance, triangle counting, this sort of problems. They all have different sort of polynomial roadblocks to getting better polynomial time algorithms. And this recent sort of fine-grained complexity successes have forged lots of nice connections between these problems, and explain that actually there are relatively few common roadblocks to improving. So that's been hugely successful. This paper sort of initiates a study of this, but for I/O complexity, right? So the I/O model, you're not worried about time. Instead, you're worried about memory accesses, and arguably, depending on practical people you talk to, so the I/O model is maybe the right model to actually clock time algorithms. And the landscape of I/O complexity currently is a bit of a mess. It's very mysterious. We don't have very many results. And this paper sort of takes this approach of reduction-based, sort of fine-grained I/O complexity, and they show a bunch of different results that hopefully will kind of open the floodgates for a much better understanding of I/O model. So anyway, so that'll all I'll say about that. So the next talk, the ETH hardness of approximating two CSPs and directed Steiner networks. So most literature on constraint satisfaction problems is kind of in this model where your kind of alphabet, the different outcomes that your variables can take is very small. Maybe it's true, false. Maybe it's something else small. But you have lots and lots of variables. So this work looks at kind of the opposite setting, where you have maybe relatively few variables, but each variable can take lots and lots of different outcomes, and you're interested in trying to understand the hardness of sort of various approximation problems there. So this is really nice and offers kind of a quite different viewpoint towards these CSPs than maybe the papers you're more used to seeing about CSPs. Okay, and then the last talk of the conference, fast and deterministic constant factor approximation algorithm. So Avia does such a good job with his talks, I wasn't going to say much about this. Maybe I'll just, should I just leave it at that? Or, no, okay, okay, right. So this paper proves that, if you have a subquadratic constant factor approximation algorithm for the longest common subsequence problem, then this would result in some, amazing, surprising circuit lower bounds. So this results from a technical standpoint, so it builds on these kind of distributed PCP challenge problems that were introduced last year. And there's some exciting stuff coming from that. And then from in this paper, you guys introduced this tropical tensors problem, which seems pretty cool. It seems like it should have other connections, and so that's something to. Okay, so without further ado, I guess Andrea is going to give the first talk. Oh, yes. Yes.